Good morning and happy Thursday. Today is day 117, and today we're going to continue working with transformations, and our big focus is going to be on congruent and similar figures and how we're going to use transformations to prove whether figures or shapes are congruent to each other and whether they're similar to each other. By now, when you're watching this video, you should have already read through today's objectives and key terms. Those are right here. And you also should have already attempted to work through and complete all of today's exploratory problems, part A and part B, and you should have been doing that work with your partner already. So at this point, you're analyzing your work on these exploratory problems, and in the interest of time, I'm going to work pretty quickly through today's video recap. The very first question we were asked, part A for the exploratory problems today, says describe a series of rigid transformations proving triangle ABC, the purple triangle up here, is congruent to triangle ABC prime, and that's that green triangle we see down here. Anytime we're asked to describe a transformation set or a series of transformations to prove two things are congruent, we can really only use rigid transformations. We need to be using translations, reflections, and rotations in order to prove that two figures are the same size and same shape, again, because congruent means same size, same shape. And if we use these rigid transformations, we're not going to be changing size or shape. We're just dragging them, flipping them, spinning them. They always stay congruent to each other if we use one of these three rigid transformations. The challenge today is it's going to take a couple series, or a series, which means a couple of steps or two different transformations to get from purple to green. The main thing we're going to have to see here, what are we going to have to do to get triangle ABC's orientation, the way in which it points, to be the same as ABC, the green prime one, where it's going to map to. And we're going to be needing to use a reflection. So hopefully you and your partner saw we need to use a reflection. And whenever we use a reflection, again, we want to be taking this purple triangle here and flipping it over across this y-axis so that it lines up at least vertically with the green triangle. So as I describe that reflection, I want to reflect the purple triangle across this y-axis to flip it from side to side. So I would say across the y-axis, and that's the precise description we're looking for when we talk about our reflections. Now, if I were to flip that purple triangle, I'm going to make a copy of it and show you a reflection across the y-axis. I'm just going to color this one gray. If we flip that and do a reflection across the y-axis, we could see 2 units away here, 2 units away there, and it flipped across the y-axis. It still needs to be dragged down to the green triangle. So the question becomes, how far do we need to drag down to get to that green triangle? I would look at the top point, this new point A, and it's sitting at a y value of 5. The new y value is -2. So I know I would need to drag down 7 units in total. You could have looked at another point, the B and the C have a y value of 1. And for the green triangle, B prime and C prime have a value of -6. So we would go down by 1 and 6 more. Again, that's drag down 7 units. So the second step in our series would be a translation, because that's what it means to drag down. And we would go down by 7 units. So the precise description we're looking for there is how many units we're going down by, so direction and magnitude. At this point, if you struggled on part A and part B, I'm going to encourage you to pause this video, work with your partner, and try to figure out part B on your own now that you understand this type of question a little bit better. So you're going to describe a series of transformations. This time we're going to need to prove these two are similar. So if you need to, pause the video. I'm going to continue and explain this problem. First, reading the question, describe a series of transformations that proves quadrilateral ABCD, this rectangle here, is similar, and we'll explain that word in a second, similar to quadrilateral ABCD prime, and that's the smaller blue rectangle up here. First thing we need to recognize and understand from the last couple days, two figures are similar if they have the same shape. And we started to realize that dilations were another transformation we could use, and even though they changed the congruence, they would change the size, and two dilated figures are no longer congruent, they would keep the same shape and could still be called similar. So for this problem, we're actually going to have 4 different transformations that we could pick from. If we want to prove the orange rectangle is similar to the blue rectangle, we have 4 transformations we could use that would result in these being similar. The biggest thing we needed to see here, hopefully all of you recognized, we needed to be doing a dilation here. We needed some type of dilate because the blue rectangle we can see is significantly smaller than the orange rectangle. The key, the original AB 4 units, the new AB 2 units, our scale factor is going to be 1/2. And in my case, I'm going to show you what I would do with that orange triangle, quadrilateral, rectangle at least. I would shrink towards point A. The reason I'm choosing to shrink towards point A here is that I recognize point A and point B line up here. So it would be great if we could drag point C and point D up there, and that's exactly what happens when we dilate by a scale factor of 1/2. So I'm going to put that in pink there. That was our first step there, is we dilated scale factor of 1/2, and we wanted to drag towards A, so we would say centered at point A. Everything in the dilation was moving towards point A. And then at that point, all we would need to do is a translation. Point A we see as an x value of 1. The new point A prime, has an x value of -4. So we would have to drag 5 units to the left. Again, that's what we're talking about with precise descriptions for our transformations. If you see it's a dilation, tell us the scale factor. Tell us where that scale factor is centered at. And if it's a translation, tell us the direction, in this case left, and how many units it goes. I'm going to encourage and stress with all of you, make sure you are filling out part C, writing about one new thing you learned about transformations from today's Explore problems before you move into the practice problems today. Thanks for watching to the end of the video. Good luck the rest of the way. Definitely let me, Miss Stewart, or Mr. Chu know if you need any help.